EDM uses an electrical arc to burn away material. There is no cutting force applied to the workpiece, and it can be used to machine parts that would be impossible with conventional machining, e.g. very hard metals, intricate geometry, or very delicate workpieces. This is the head from an old tap burning machine, which I've been saving for years for a project like this. It's old, dirty and rusty, and I don't have electronics or any other parts for it. I'm going to reuse the micrometer screw and the precision slide, which still works very nicely. I need to find a suitable power supply to create the EDM arc. I have this old broken welder. The transformer is still good. And it can provide plenty of current. But even with a capacitor across the output, it only produces around 48 volts, which is barely enough. I also have this supply, only 4 amps, but 60 volts, which is closer to what I need. So I'm going to use this one.
Aww.
This is the circuit I'm using for testing. It's quite simple. Resistor R1 limits the maximum current drawn from the supply. For this I'm using a heating element. It has a resistance of a few ohms. Current through the resistor charges the spark capacitor. This delivers short but very high current pulses to the electrode. A low ESR capacitor should be used. For now, I'm using an ordinary electrolytic one, which works, but it does get hot. The current pulses are turned on and off using an IGBT, which is a type of transistor that can handle high voltages and current. To drive the IGBT, I built a microcontroller circuit that allows me to adjust both the pulse width and frequency. I found around 5 kHz at 10% duty works well, i.e. the pulse is on for 20 microseconds and off for 180 microseconds. A spark will only occur if the electrode is close enough to the workpiece, but not touching. Otherwise a short circuit is created. Normally the workpiece is submerged in a dielectric fluid, such as a special oil. With the correct spark settings and careful selection of appropriate workpiece and electrode materials, the workpiece will be eroded much faster than the electrode. A 3mm hole made in 23 seconds is a metal removal rate of 18 mm cubed per minute, which is much better than I was expecting. The hole produced is perfectly clean and round on both sides. For comparison, here is the same size hole made with a hand drill. The electrode itself has minimal wear, some light pitting, and the corners are slightly rounded. So what next? First, I plan to add a stepper or servo motor to drive the screw and move the electrode at a controllable speed. I need a way to measure the arc current and provide feedback to regulate the speed of the electrode. The dark clouds seen here are particles of aluminium from the workpiece. These need flushing out of the cut to improve the surface finish. This can be done with a jet or stream of fluid. For prolonged use, the fluid also needs filtering or constantly replacing to remove the particles. I might also add some sort of compound table for the workpiece. This is going to be a sync type EDM rather than a wire EDM. But it will be useful to be able to accurately reposition the workpiece for taking multiple cuts. In the future, I might want to add a wire EDM option. This will require moving the workpiece in the XY plane.